Welcome back to another exciting episode of our Bitcoin Tech Tales series. In the last episode, we learned about the difficulty target, which regulates the time a miner needs to find the nonce. In this episode, we'll uncover the vital role played by the nonce in securing the blockchain. We've titled this episode, Finding Nonce. So, let's jump right in. Miner searches the nonce number with the proof of work algorithm. In our fictional world of Bitcoin, we call him PoWY. PoWY is a hashing algorithm that generates a hash of the block header's data. On his head, there is a fixed place for input data, where all 6 tiles of the block header have a place. His job is to create the block header's hash value smaller than the difficulty target. As you already know, the value of the nonce is set to 0 by default when the block is created. Let's make the block header's hash now. In our case, when the value of the nonce is 0, the value of the calculated hash is not smaller than the difficulty target. So how can PoWY generate the desired hash, given that all tiles except the nonce have block-specific fixed values and, therefore, only one possible hash? In addition, we cannot predict the hash value if we know the input data. The only way to find the wanted hash is to provide an additional value in the block header that we can change. This extra value is the nonce. Since the nonce has to change very often until, by random, the block header's hash meets the desired criteria, we gave PoWY a permanent connection to the display of the nonce and the block header's hash. PoWY tries many nonce values until he randomly discovers the valid value that produces a block header's hash value less than the specified difficulty target. In our fictional Bitcoin miner node, the block is already loaded with transactions, and the block header with block-specific information. The miner's task at this stage is to search for a nonce value that will make the block header hash less than the difficulty target. The miner places the block header plates of the candidate block in the head of PoWY. PoWY tirelessly examines an immense number of nonce values until he discovers a valid hash. This can only be achieved through specialized hardware and substantial energy consumption. Thus, the valid nonce value proves that a miner invested work and spent money for consumed energy. That is why we refer to this algorithm as proof of work. When PoWY finds the nonce whose value caused the block header hash to be less than the difficulty target, he stops his work. With the correct nonce, he found a new valid block. Therefore, the miner immediately informs the Bitcoin network about it. After the miner finds the correct nonce, they replace the 0 value of the nonce in the block header with the newly found one. This transforms the candidate block into a valid new one, meeting the Bitcoin protocol requirements. The miner then propagates this new block to the Bitcoin network. Miners compete to find the nonce and create a valid new block first. The first miner to succeed gets his block added to the blockchain, and he gets paid. Others get nothing. Once the other miners receive the news of the new block, they drop their candidate block and start building the next one. The miner who found the block attaches it to the blockchain. However, all other Bitcoin nodes with blockchain must verify if the received new block is constructed by the Bitcoin rules before connecting it to the blockchain. I hope you enjoyed this episode, where we examined how miners use the proof of work algorithm to find the nonce and, therefore, the new Bitcoin block. Please join us for our following episode of the Bitcoin Tech Tales series, where we'll explore how nodes verify a new block before adding it to the blockchain. Be sure to tune in to learn more. See you, folks.